Good morning, student. Subject electronics devices and circuit. So, from the chapter number 4, oscillators. So, last session we have seen what is mean by oscillator. Then, what is the difference between the oscillator and amplifier. Then, we have seen the difference between alternator and oscillator. Then, we have seen classification of oscillators. So from that sinusoidal oscillators and non-sinusoidal oscillators we have seen. So in sinusoidal oscillator there are four types: two-nodal circuit oscillator, RC oscillators, crystal oscillators, negative resistance oscillator. So up to this we have completed in a last session. So today we are going to see the next points from the fourth chapter. So then next we are going to see the nature of sinusoidal oscillations. So the nature of oscillations in a sinusoidal wave is generally of two types. They are damped and undamped oscillations. Okay. So the nature of sinusoidal oscillations we are going to see. So the nature of oscillations in sinusoidal wave is generally of two types. They are damped and undamped oscillations. So let us see the damped oscillations. The electrical oscillations whose amplitude goes on decreasing with time are called as damping oscillation. Okay, what is meant by damped oscillation? Electronics oscillation whose amplitude goes on decreasing with the time are called damped oscillations. So the frequency of the damped oscillations may remain constant depending upon the circuit parameters. Okay, so damped oscillations means what? The oscillations whose amplitude goes on decreasing with time are called damped oscillations. So the frequency of the damped oscillations may remain constant depending upon the circuit parameters. So this waveform shows that y-axis represents amplitude and x-axis represents the time. So here electronics oscillation amplitude goes on decreasing with time. So it is known as the damped oscillation. So damped oscillations are generally produced by the oscillatory circuit that produces power losses and doesn't compensate if required. Okay. So damped oscillations are generally produced by the oscillatory circuit that produce power losses and doesn't compensate if required. So let us see undamped oscillation. So the electrical oscillation whose amplitude remains constant with time are called undamped oscillations. Okay. So the electrical oscillations whose amplitude remains constant with time are called as undamped oscillations. So the frequency of an undamped oscillation remains constant. So it is known as the undamped oscillation where amplitude is constant as well as the oscillation frequency also remains constant. So undamped oscillations are generally produced by the oscillatory circuit that produces no power loss and the following compensation techniques if any power losses are occurred. Okay? So oscillations are two types, damped and undamped. In undamped, amplitude is going to in damped, amplitude is going to decreasing with respect to time, and in undamped, the amplitude of the oscillation remains constant. So in a damped oscillation, power losses take place. In undamped oscillation, there is no any power loss. So an amplifier with positive feedback produces its output to be in phase with an input and decreases the strength of the signal. Increases the strength of the signal. Okay, so an amplifier with positive feedback produces its output to be in phase with the input and the increases the strength of the signal. So positive feedback is also called as degenerative feedback or direct feedback. Positive feedback is also called as degenerative feedback or direct feedback. So this kind of feedback makes the feedback amplifier and oscillator. Okay. So this kind of feedback makes the feedback amplifier and oscillator. So the use of positive feedback results in a feedback amplifier having closed loop gain greater than the open loop gain. If the use of positive feedback results in a feedback amplifier having closed loop gain greater than the open loop gain, so it resulting in instability and operates as an or oscillatory circuit. Okay, so the use of positive feedback results in a feedback amplifier having closed loop gain greater than the open loop gain. It results in instability and operates as an oscillatory circuit. So it results in instability and operates as an oscillatory circuit. So as oscillatory circuit provides a constantly varying amplified output signal of any desired frequency. Okay. So the use of positive feedback result in a feedback amplifier having closed loop gain greater than the open loop gain. It results in instability and operates as an oscillatory circuit. An oscillatory circuit provides a constantly varying amplifier output signal of any desired frequency. Then the next is the Barkhuen criterion. So with the knowledge we have till now, we understand that a practical oscillator circuit consists of a tank circuit. Okay. So with the knowledge we have till now, we understood that a practical oscillator circuit consists of a tank circuit, a transistor amplifier circuit, and a feedback circuit. So let us now try to brush up the concept of feedback amplifiers. To derive the gain of feedback amplifiers, okay, so let us see the Barkhuen criteria. So let us see the principle of feedback amplifier. A feedback amplifier generally consists of two parts. They are the amplifier and the feedback circuit. The feedback circuit usually consists of resistors. The concept of feedback amplifier can be understood from the following figure. Okay. A feedback amplifier generally consists of two parts. They are amplifier and feedback circuits. So the feedback circuit usually consists of a resistor. So the concept of feedback amplifier can be understood from the following figure. So let us observe the following figure, which gives you the Barkhuen criteria. So focus on the Barkhuen criteria figure. So have you observed that what we have learned from this? because already we have seen the feedback amplifier. So which type of this feedback amplifier? Voltage shunt feedback amplifier, isn't it? So here amplifier with gain A is in the circuitry and feedback circuit which is having factor beta. So from above figure, the gain of the amplifier is represented as A. The gain of the amplifier is ratio of output voltage V0 to the input voltage VR. So the feedback network extracts a voltage Vf is equal to factor beta into V0 from the output V0 of the amplifier. So this voltage is added for positive feedback and subtracted for negative feedback from the so this voltage is added for positive feedback and subtracted for negative feedback from the signal voltage here. So let us see that the Barkhuen criteria. So for a positive feedback, so Vi is equal to Vf plus Vf. So Vf is represented as beta into V0. So the quantity beta is equal to Vf divided by V0 is called as feedback ratio of feedback fraction. So the output V0 must be equal to the input voltage. So that is Vs plus beta B V0. Multiplied by gain A of the amplifier. So hence Vs plus beta V0 into A is equal to V0, or we can say let's multiply with this A inside. So AVs plus AB V0 is equal to V0. So take this term this side, so it becomes AVs is equal to V0 into 1 plus A beta. So V0 is common in both the terms. So we have taken outside that. So therefore, again rearrangement of this equation, V0 divided by Vs is equal to A divided by 1 minus A beta. Let AA be the overall gain. So gain with the feedback of the amplifier. So this is determined as AF is equal to output voltage divided by input signal voltage, that is V0 by Vs. Okay, so by using this figure, that is the amplifier with feedback circuitry, we have reached up to the AF is equal to output voltage divided by input signal voltage. So, from the above two equations, we can understand that the equation of gain of the feedback amplifier with positive feedback is given by AF is equal to A divided by 1 minus A beta. So where A beta is the feedback factor or loop gain. So if A beta is equal to 1, AF is the infinity. Thus gain becomes infinity, that is there is a output without any input. In another word, the amplifiers works as oscillators. Okay, if the A beta is equal to 1, AF is nothing but the infinity. So thus the gain becomes infinity, that is, there is a output without any input. In another words, we can say amplifier works as an oscillator. So thus condition A beta is equal to 1 is called as Barkhuen criteria of oscillation. Okay, so the condition A beta is equal to 1 is called as Barkhuen criteria of oscillation. So this is very important factor to be always kept in mind in the concept of the oscillators. Okay. Okay, so today we have seen that the nature of sinusoidal oscillations, where that they are generally two types. One is the damped and another is the undamped oscillation. So damped oscillation is nothing but the electronic oscillation whose amplitude goes on decreasing with the time. So frequency of damped oscillation remains constant depending upon the circuit parameters. And in undamped oscillation, the electronic oscillations whose amplitude remains constant with time are called as the undamped oscillations. So this is nothing but the difference between damped oscillations and undamped oscillations. So undamped oscillations are generally produces an oscillatory circuit that provides no power losses and follow compensation techniques if any power losses occur. So for the oscillation purpose, we have to focus on the Barkhuen criteria. So Barkhuen criteria is nothing but that the amplifier and feedback factor product is equal to 1. So how that? So oscillator circuit consists of tank circuit and the transistor amplifier circuit and a feedback circuit. So means what is the concept of the feedback amplifier? To derive the gain of the feedback amplifiers, what we are going to see? There are two parts, amplifier and feedback circuit. So we have to take into the consideration that the circuit, that the figure configuration which having amplifier as well as that the feedback circuit. So in this figure, amplifier with gain A and the feedback circuit is also there. So capital A shows that the gain of the amplifier and beta shows the feedback factor of that block. Vs is the input voltage, Vi is nothing but the amplifier input, V0 is the output one, so which is fed to the feedback circuit, and feedback circuit will also generate the Vf, that is beta into V0. So from above figure, the gain amplifier is represented as A. So Vf is equal to beta into V0. So as that the signal voltage Vs, so for the positive feedback we can say Vi is equal to Vs plus Vf, and this Vf is replaced by beta V0. So beta is nothing but the Vf by V0 because these are two gets cancelled and it's called a feedback ratio of feedback fraction. So the output V0 must be equal to the input. So when we derive or rearranging this, we are getting that the AF is equal to output voltage divided by input signal voltage. So V0 divided by Vs. So here we can say that AF is equal to A upon 1 minus A beta. So this factor, that is feedback factor and gain, is equal to 1, and that is the condition of the Barkhuen theorem. And this is very important factor to be always kept in mind in the concept of oscillator. Thank you.